MSc Part 2 Semester 4. In that paper 2 Synthetic Organic Chemistry 2, the unit 2 is the Designing Organic Synthesis 2. The next point is a two group carbon-carbon disconnection is a 1,3 difunctionalized compound and 1,3 difunction 1,3 difunctionalized compound. In that first is a 1,3 dicarbonyl compound. Okay, as the shown is a disconnection of a 1,3 dicarbonyl compound means that we have looking for the reaction which is a acylation of a enolate anion, and due to the 1,3 relationship between the carbonyl oxygen and the disconnection is indicate the 1,3 dio. So the firstly is in 15 molecule is a 1,3 disconnection and the formation of this enolate. Okay, and this possible when esters or acid chloride, the perfumely compound can be disconnected to the enolate of a ketone and ester. The firstly is the retrosynthetic analysis, the 1,3 disconnection in the carbon-carbon bond and the formation of this ketone molecule and ester molecule, enolate and ester molecule. The reaction can be carried out by the combining the ketone with the ester and the base, often the ETO is strong enough to produce the only small concentration of a enolate, and the last step is the acid release the target molecule. This last step applied to all the reaction on this type but not actually usually written down. The synthesis is the first is a OET is as a base, so abstract the hydrogen from the ketone and the formation of the enolate, and this enolate is attached to the ester and the OET group is lost, and this next step is the OET is abstract the proton and the alpha beta unsaturated compound and enolate formation. Last step is a H plus in the formation of this compound. So this synthesis was carried out by the Claisen and the reaction known as a Claisen condensation. Then ethyl acetate to acetate is also made in this way. In this case, the starting material are the two molecules of the same ester, and the synthesis often known as a Claisen ester condensation. So the retrosynthetic analysis first is a 1,3. Firstly, 1,3 disconnection, then OET and formation, and the synthesis is the simple is the two moles of a ester molecule and the formation of this compound. Then the next is the beta hydroxy carbonyl compound. This due to the same disconnection at a lower oxidation level, the ester being depleted by the aldehyde or ketone. The compound may look the complicated, but the one disconnection is possible, and the starting material are the two molecules of the same ketone. The first is the retrosynthetic analysis is a 1,3 disconnection between this carbon-carbon bond and the formation of this enolate and ketone, and the synthesis is the in the ketone molecule is abstract the hydrogen proton from this ketone and the formation of a target molecule. Other compound for many needs FGI before the disconnection. Other compound ला काय लागतं की FGI लागतो, functional group interconversion is the firstly retrosynthetic analysis. In that the first step is the FGI, means functional group interconversion. So reduction step, the alcohol is converted into the ketone. The 1,3, then next step is the 1,3 disconnection, formation of this ketone molecule. Synthesis is the two moles of a ketone in presence of a base and H2 nickel, the formation of the target molecule. The condensation of aldehyde with itself in aldol reaction. Some people refers to all these condensation where the aldehyde or ketone are involved in the aldol reaction. The retrosynthetic analysis is the 1,3 disconnection and the formation of aldehyde and carbanion. The synthesis is the aldehyde is reacted with NaOH and the formation of the target molecule. And the alpha beta unsaturated carbonyl compound is the dehydration of a beta hydroxy carbonyl compound is very easy because the portion of to be removed is the enolic and the product form the stabilized by the conjugation. So the Firstly, beta hydroxy carbonyl compound is reacted with acid or base, the formation of the enone molecule. And the full retrosynthetic analysis of an enone or the alpha beta unsaturated carbonyl compound should be and the FGI followed by the 1,3 disconnection. The dehydration often occurs during the condensation, so that the aldol needed not be isolated, and therefore the disconnection of the enone is directly right to the two carbonyl components. The retrosynthetic analysis. The firstly is the alpha beta unsaturated target molecule with the FGI is the functional group interconversion dehydration step, then formation of the beta hydroxy ketone molecule, and then again step is the 1,3 disconnection, formation of the 2 moles of a ketone. And then in this the synthesis is the firstly 2 moles of a ketone is reacted H plus and the formation of this alpha beta unsaturated molecule, ketone molecule. The retrosynthetic analysis is the alpha beta unsaturated ketone and the formation of this 2 moles of a ketone. And this is a very important disconnection. We simply disconnect the double bond and write the carbonyl group to the beta atom. An example is the disconnection of gives the two identical isomers. So the firstly is the retrosynthetic analysis. The one alpha beta unsaturated is a breakdown, carbon carbon bond is a disconnection, and the formation of this ester molecule, cyclic ester, and then the 2 moles of a cyclic ester is reacted with the base and the formation of this target molecule. Thank you.